floods, high winds, tornadoes, hail, all warning signs of the transition from winter to spring. We've already seen so many examples of severe weather so far this season.
During the next 30 minutes, our weather team will break down some of the most important stories to get you ready for spring. This is Surviving the Storm.
Surviving the Storm, a KSHB 41 weather special, sponsored by NFM.
It was just a few months ago when we joined you with our winter weather special. A lot has happened in the week since it aired. Meteorologist Jeff Penner recaps what we saw last winter.
The last two spring and summers, we dealt with drought conditions. What will the 2024 growing season bring? More drought, too much rain, or just right? In order to make the forecast, we need to look back at what this pattern has been doing since it set up in early October. In other words, we use the LRC, which states that the pattern sets up in a unique way in October and November and begins cycling through the winter, spring, and summer before a new unique pattern sets up again the next fall. We also factor in whether there was an El Nino or a La Nina, and this season we have been in a rather strong El Nino. This unique pattern delivered 12.06 inches of rain and melted snow, which is 102% of average. Snowfall, however, was around 5 inches below average, with 13.2 inches of snow recorded. Every month saw above average temperatures with the exception of January. December was the 7th warmest, and February was the 3rd warmest in our recorded history, which started in 1889. When the pattern started, drought conditions were getting out of control, as most of the region was in a moderate to severe drought, with southeast Kansas and southern Missouri in an extreme drought. The near to above average precipitation has helped reduce the drought considerably to most locations, either in no drought or just moderate. What does this mean for the upcoming spring and summer? Our forecast at the end of the show.
There are several types of severe weather that take up the main stage during the spring season. The biggest of which, floods, hail, wind, and tornadoes. We send you alerts all the time when the conditions turn dangerous for the Kansas City area. I wanted to take a closer look into the science behind these alerts. That brought me here to the National Weather Service office in Pleasant Hill. I'm here to take a tour and hear from those that determine our storm severity.
Quiet out here, but it's like quiet chaos is the way I describe it.
Communication is key. For Jonathan Kurtz and his team, where work to keep Kansas City safe happens before storms strike.
It's pretty fast, and again, we're just constantly communicating on the floor.
Their second-by-second decisions save lives.
It's like a duck on water, you know? It's like, it looks calm, the glassy surface of a pond, and then underneath the duck's feet are going like crazy.
They start their forecast around 7 days out. If a big storm appears to develop, forecasters can be on duty 24 hours a day leading up to the storm. Everyone plays a role in severe weather events. There's broadcast meteorologists like myself that show those conditions to all of you at home. The team at the National Weather Service gathers the data needed in our broadcast, like mesoscale meteorologists who monitor and determine the instability of storms. Then there's the warning meteorologists. They determine when to call the warnings that go out to the Kansas City area.
Let's say they see a hail core starting to develop. They're going to draw the polygon that you see on TV that was sent out to the world.
Jonathan talked about using this process during a big storm in March. His team considered issuing a tornado warning at one point until cold air snuffed out a wall cloud that could have formed a tornado. But they did issue another warning when it showed other dangers.
You know, the warning forecaster was like, okay, you almost have breathed a sigh of relief. But the problem is it's still throwing out 3-inch size hail, which is just as damaging and can be dangerous for folks who are outside. That's when we decided to put the considerable tag on the warning for considerable damage.
So every time you see myself or any other member of our weather team on TV, just remember the faces you don't see that make this communication possible.
We need each other, and it's the truth. Like, without the three of us working together really closely, I don't think we serve the public as well as we could if we were by ourselves.
While they are rare, you never know when a tornado can strike your home. Make sure you know the tornado shelters near you. There may not be as many FEMA-regulated shelters as we think. Cassie?
The Kansas City area includes a little over 2.2 million people. But a recent mapping project done by Dr. Craig Cece shows that our area has only 41 safe places. To put that in perspective, as a whole across the state of Alabama, there are over 600.
There are definitely holes I've noticed. across much of the metro, including on the Kansas side, but also on the north side of the metro.
FEMA designates that a safe place must provide near absolute protection for its occupants during an extreme wind event. In KC, that standard is 250-mile-per-hour winds for at least 3 seconds. That means the structure should stay in place through an EF5 tornado. But there's only been one tornado of that magnitude to impact the Kansas City area, and that was 67 years ago. But EF0 to EF5, Wyandotte County Emergency Manager Matt May treats all tornado threats the same.
During a race event, I've had a tornado on the ground within about 12 miles up in northern part of Leavenworth County. And I was fortunate that National Weather had a meteorologist assigned to us in the command center, and we were actually able to consult with him and consult with NASCAR leadership so they would know we were about to make that decision collectively.
On April 25th, 2009, the National Weather Service confirmed a tornado on the ground just to the southwest of the racetrack. Luckily, the stands were already empty as NASCAR officials had suspended the race 30 minutes prior due to thunderstorm activity. With no shelter nearby, what's the plan if there's a tornado threat?
The stands themselves don't provide a lot of shelter, and so we try to give them enough lead time to get out of the stands and into their cars.
The Kansas Speedway has one of the fastest entry and exit plans in the country, and they say they can get their fans to the highway in 90 minutes, while other tracks can take 2 to 3 times that length. But tornadoes move faster than that. So what do you do if you get stuck in your car and there's a tornado nearby?
If you're in your car and a tornado is coming, they recommend turning the ignition on because it makes sure the airbags are activated. So we tell them turn the ignition on, stay in the car. You might get rolled, you might not, but you're going to be a far better shape than if you're out in the open.
From NASCAR to shopping, the Legends area in Wyandotte County holds vulnerability as an outdoor space. But it's been a while since we've seen a destructive tornado move towards that area. The most recent, the Linwood tornado 7 years ago. Luckily, that lifted right before Bonner Springs. Just south of the Kansas River, though, another heavily populated area sits without any FEMA shelters. But for Joco, it has been 60 to 70 years since they've seen a destructive tornado.
A shelter is just one piece of that preparedness. And what we always want to drive home to our residents and visitors within Johnson County is to have a plan. Identifying in your home or place of business or places you frequent, if you have children's schools in Johnson County, knowing that if you're in that place when severe weather is imminent or it's happening, there's a tornado warning issued, where can you go to seek shelter?
And practice that plan. Build some muscle memory, and don't forget to talk to your kids about what to do when a tornado watch or warning is issued.
Tornadoes can be powerful, but as Mike showed us earlier, don't underestimate hail. And there could be more of it in Kansas City's future. One study shows warning signs of the metro becoming a bigger hub for hail. As we go into the warmer season, storms develop because of the heat and humidity in the atmosphere and coming off the ground. The storms can develop closer to Kansas City, where city infrastructure causes warmer temperatures in outlying areas, according to a study that simulated a storm that occurred in Kansas City in 2015.
Kansas City urbanization intensified the storm, and the pulse is toward the city. So that's changed the storm path.
The difference in temperature and moisture between the city and rural areas creates something like a miniature front, with the city being warmer and drier, and then cooler and wetter air in the outlying areas. And then that caused the storm, which initially developed on the northwestern parts of the Kansas City metro, to then bend toward and closer to 435, and therefore impacting more of the heart of the city. And then when they simulated the storm without the city infrastructure, it took a little bit of a different path. And you could see it didn't have that bend to it. It just kept on moving away from the city. And when you look at both of the paths that these storms took, again, both simulated, but they managed to just replicate what it looked like in real life, you can see the no city one takes a much severe angle away. And when they ran this simulation, they noticed that this one was pretty close to what actually occurred in real life. This last part is interesting. Fahn's study found that the aerosols, or air pollutants, can create larger and more frequent hail. Those pollutants give warmth for the storm and more places for the hail to then grow. And the more hail to grow, it can then become larger hailstones as well.
If we don't have the urbanization impact to pull the stone toward the city, then the erosion effect will not be that significant.
That means storms with hail, which causes 60% of storm damage nationwide, may be targeting the city more frequently. And in the future, if the city continues to grow, that effect may become stronger.
The impact of urbanization on the severe storms will certainly increase with the further expansion of the urban area. We are not clear if the impact will be certainly just increase the hail or decrease the hail.
And that decrease may have occurred in the middle of March as hail sizes got smaller as the storm moved across the city, possibly because of the drier air over it. Look at the hail size that was in Shawnee. It was tennis ball size hail. We got to Clay Como and it was closer to ping pong ball size hail. And by the time we got to Liberty, even smaller than the sizes of quarters.
Every storm we encounter in Kansas City is different, and the impact the urban infrastructure has on the storm could be different as well.
A major factor of storms in the sky can be found on the ground. The role dew point plays behind those storms.
The number one ingredient for a severe thunderstorm, let alone any thunderstorm or precipitation, is water vapor, moisture in the air. A severe thunderstorm can use 1.1 billion pounds of water vapor. Now, in the plains, 90% of the water vapor comes from the Gulf of Mexico. Evaporation over the Gulf of Mexico produces the water vapor. This water vapor gets transported north. If there is enough water vapor along with other ingredients, such as fronts and wind shear, you can get severe thunderstorms. How do we know if there's enough water vapor in the air to create a severe thunderstorm? We use the dew point temperature. The definition of a dew point from the National Weather Service is this. The dew point is a temperature the air needs to be cooled to at constant pressure in order to achieve a relative humidity of 100%. At this point, the air cannot hold more water in the gas form. If the air were to be cooled even more, water vapor would have to come out of the atmosphere in the liquid form. The dew point temperature usually needs to be in the 50s and low 60s at least for severe weather. So the dew point measures the amount of moisture in the air. For example, if the temperature is 67 and the dew point is 43, the humidity is 42%. This means the air has to cool to 43 for the air to be saturated and dew to form. At night, given the right conditions of a clear sky and light wind, and the temperature cools to 43, the humidity rises to 100% and the moisture condenses out to form dew. Now we can do a simple experiment to demonstrate the dew point.
But this is a readout of our outdoor weather station. It says right now outside it's 58.6 degrees, the relative humidity is 69%, and the dew point is 48, meaning the air mass outside has to cool to 48 degrees for dew to form, or for there to be 100% humidity. Now, let's go outside and prove it. We have a thermometer, a glass of water here, a vase of water, and ice. So the water temperature at this moment, it's tap water, it's reading at about 74 degrees. So if we want dew to form on the outside here, that means it would reach the dew point. We have to cool this water to 48 degrees, and the way to do that is with ice. So let's give this a try. So we're gonna put ice in here. Actually, now I can see it. There's actually dew here on the glass. It's forming right at 48 degrees. How about that? So dew formed on the outside of the glass at 48 degrees. What we've done is take the outside air and cool it to 48 degrees right near the glass with the ice. So the humidity's got to 100%, and then it cooled it even more, and it started to condense out. The moisture condensed out, and there we are with dew. We have reached the dew point. The humidity is 100% right next to this glass.
If your sinuses are flaring this spring, blame the weather. An allergist with Children's Mercy tells me there's a lot of complexities to allergy season, and the recent warm months impact sufferers.
Ah, spring. It's a beautiful time of year as flowers are blooming and the grass is growing. But scenes like these could make you sneeze. This year has been especially difficult for pollen and mold sufferers.
So this year we certainly saw that pattern of tree pollination happening as early as February.
Makes sense. We had our third warmest February ever recorded in Kansas City, with the average temperature of 10.5 degrees above normal. And the pollen pattern follows the weather pattern.
In terms of the kind of pattern of weather, that doesn't always determine, what a pollen pattern would look like, but I can tell you that with humidity levels going up, mold levels, would be anticipated to go up at that time.
While myself and the weather team track daily pollen and mold counts, it's hard to know when individuals have a more severe reaction than others.
In Kansas City specifically, we have a large amount of pollens that get blown in, especially from western Kansas.
And living in a pollen-rich environment, I asked Dr. Padia if heavy rain or changes in the weather could help those suffering.
You would think that after a rain, everything washes out. That's not the case necessarily. There are certain pollens that can even become disturbed or higher in the air after a rainy time has happened. So safe to say that there's no safe weather pattern. Really, the time that we anticipate pollen levels specifically to drop off, is when there's been a frost.
But frosts are changing. The North American pollen season has lengthened by 20 days on average. In Kansas City, we're seeing less cold less often. Our warmer winters are allowing the spring to come to life sooner.
And I think that's a trend we've been observing over the last couple of years. We're noticing that the season of spring is kind of starting early and earlier each year due to a variety of different factors. Generally, as things are warming, pollens have the opportunity to bloom when the climate is warmer. And so we have observed that pattern over the last couple of years, actually, where we are seeing the pollination season actually happening even earlier than what we used to see.
As our allergy season evolves, know that KSHB has you covered. Head to our website to check the daily allergy report by scanning this QR code on your screen. Lindsay Anderson, KSHB 41 Weather.
Don't go anywhere. We have our final forecast predictions for spring on the other side of the break.
So here's what we are thinking for the spring and summer of 2024. We averaged 27.48 inches of rain between April 1st and September 30th. Now, rainfall will likely be near average through September. Our forecast is for 28.1 inches of rain. This should keep drought conditions away or to a minimum. Now, will we see severe weather along with the rain? We've had 2 days in March where we saw large hail with 2 tornadoes just west of Topeka, March 12th and 13th. Using the LRC, that part of the pattern returns at the end of April and then again around the second week of June. The third period to watch will be the last 10 days of May. This is the part of the pattern that brought tornadoes to the Chicagoland and a temperature drop from 73 to 12 in Kansas City. Now, bigger thunderstorm events during the summer can always have a chance to be severe due to the presence of the heat and humidity like we saw last summer. What about temperatures? Well, likely run near to above average as we do not see any prolonged heat wave issues. So it's looking just right this spring and summer as we should see enough rain to keep drought away and no major heat waves. Mike, back to you.
That will do it. Keep an eye on our page at kshb.com for the latest weather report. You can also download our free KSHB 41 app. From all of us at KSHB 41, we hope you have a fun and safe spring. Have a good day.